Good morning, everybody. My name is Tyler Harbeck, current member of IGSHPA's Board of Directors. Today, our talk will dig deeper into the topic of vaults. But first, we'll do some brief housekeeping. Look out for all the upcoming 2022 town halls and dig deeper webinars. Know that the 2022 conference is going to be held in Las Vegas in December. And know that renewals for CEUs are now required with all IGSHPA certifications. Always check out the events at IGSHPA.org. Brief descriptions and registration links are available now for any upcoming events. As we discussed, our annual conference will be piggybacked on with Groundwater Week in Las Vegas in December. And as previously stated, we're no longer waiving CEUs for 2022 renewals. Town halls and the annual conference will qualify as CEUs. If you'd like CEUs for this town hall, please send a chat message while on the Zoom meeting. Please include your name, email, and CEUs, brief calculation there for your reference. Please make sure to type your questions in the comment section. The town hall facilitator will field them for the speaker. If we don't get to your message today, we'll do our best to get back to you as soon as possible. Please mute your microphone unless you're speaking, as this session will be recorded and viewed later. Our speaker today is Joe Pejsa, professional and specialist in geothermal vault sales. Joe is the geothermal vault sales representative for Infra Pipe Solutions for all of the United States and Canada. He's been with Infra Pipe Solutions, formerly Upinar, for 9 years and has a combined 18 years of experience in the geothermal well field sales, service, and design, working for Infra Pipe Solutions, ISCO, and GHP systems. His expertise is in geothermal well field estimating and technical sales. He earned his Bachelor's of Science of Manufacturing Engineering Technology from South Dakota State University in Brookings. He is a longstanding member of IGSHPA and is McElroy Fusion certified. I will now kick it over to Joe, and he will continue with the presentation.
Can everybody hear me here?
Yes, we can.
Okay.
I got you
All right.
here.
Here we go. I'm going to share my screen. I'm technologically challenged most times, so we'll see how this goes. As Tyler, thank you, Tyler, for introducing me. As Tyler said, I'm the geothermal sales, the vault sales person for Infra Pipe. We're going to talk about geothermal valve vaults. I know this topic really well, so hopefully I can stretch this out and we have lots of questions because I can hopefully answer everybody's questions and give some guidance in some way. So I'm hoping that there'll be a lot of questions because the presentation itself is not all that long. I'll try to dig into each one as I go. As you said, Joe Pejsa. I work for Infra Pipe Solutions Ltd. I do geothermal vault sales. I have worked for ISCO for a period of time, and I worked for GHP when I first got into the industry. I worked 18 years in the ground source heat pump industry and primarily focused on the well fields. I like to say from the building out, I know a lot about that, but from the building in, I really don't know much about anything. So I try to focus on what I know and answer the questions that I can answer intelligently based on that, my years of experience. What is a geothermal vault? Well, basically it is an underground structure for locating a central manifold on a ground source heat pump system or project. We take all the bores, we put them into a certain number of bores into a circuit, and then we house that manifold inside of a vault instead of inside of the building. What types of vaults are there? There's a number of vaults out there. Typically what we see a lot of is, HDPE cylindrical size like we make. There is an HDPE sheet stock one that's also made in the industry, and there's several concrete versions that are out there. Have seen some fiberglass, but not very many. Probably only one or two actually. Concrete on the picture here, this one was actually in Minnesota, and it was made out of, concrete pipe. It was an interesting manifold that was built inside there. And then the picture on the right is a cylindrical vault that we make currently at Infra Pipes. Common vault components. We have a lot of accessories that can go in these. We have a lot of vaults come with electric lights, outlets, some pumps, some without pumps, some with no electricity, ventilation, fans. All vaults should and are required to have an OSHA ladder. It's not really a component, I just put it in there. Something that is a kind of a nice feature that's not in a lot of vaults is slip resistant graded flooring. We have an RFP floor that's doesn't corrode and rust. 2 manways, one for flushing and one for purging. This isn't something that I see all the time, but something that the more I work inside vaults, the more over the years, it's kind of nice to have the 2 manways, just because you start putting ventilation fan tubes in, and you start putting the fill ports and all the pipes in for flushing and purging and the hoses. It becomes very clustered inside the 30-inch manway or the 36-inch manway on where the ladder is. So the 2 manway option is starting to, I'm seeing more of it. I don't see a lot of it though. What to avoid inside of a vault. We want to try to keep it as simple as possible. Probably try to put as many bores. Let me see. Keep it as simple as possible. Put as many bores together as possible on a circuit. And the cost is extremely high when we go to individual lines brought into a vault. If you look here, you can see all the threaded connections, all the components. If we can bring as many bores to one circuit and bring the 2-inch line in, it really helps the cost. There's no internal heaters. I do see heaters inside vaults once in a while, and within a year, the environment is that they don't work. They're kind of a fire hazard with the moisture in the air and some other things that happen. So I don't really recommend that. I think ventilation fans, there was a design out there that had a ventilation fan inside of the vault. And this is an issue with OSHA, because you need to have positive air pressure. So the fan needs to be outside the vault so that we can blow air into the vault to create positive air pressure to carry out any contaminants. So recommendation is the ventilation fan needs to be stored in the maintenance room. It can be stored in the vault such that when the lid, we do make it so we can hang it in the vault lid, and when you pull the vault lid up, the fan is there and ready for use. Here's an example of a vault that has all individual lines brought into it. You can see the complexity of it. There's a lot of different challenges with this kind of vault, and then also, like I said, the cost of it is extremely high. I don't know how my slides got screwed up here. But, topics for discussion today. We're going to talk about what is the location, what is the optimal location of the geothermal vault? Is there an issue with the water table? Are there underground utility issues? What are the savings that we see with a vault versus manifold? What are the expenses that we see with a vault versus a manifold? And does it need to be H20 rated? These are typical questions that I get asked when engineers or somebody calls me about a geothermal vault and if it's needed. The most common questions I receive is, how can I determine if a vault is needed? I get a lot of people that, and even Jeff with IGSHPA, he called and said, I'd like to know, when that is. And I think the ultimate answer is that I don't really know. Over my years of experience, there's been projects where vaults are, they're needed, they're necessary, but then there's also times where I've talked myself out of vaults and said, you know, it'd really be cheaper to go inside. So, you know, really the answer depends on the project itself. You know, is this a new build? Is there lots of room inside the boiler room? You know, is the room designed for the manifold plus the pumps and the equipment that's all in the building? You know, is it an existing building with an old boiler room? You know, there's a lot of things. A lot of existing buildings have small boiler rooms. I'll expand on that more. And existing buildings with tons of utilities around them. So these questions are what I have to ask myself, or ask the engineer, or somebody, you know, whoever's designing the well fields. You know, what are our challenges that we're going to face when we're putting the vault in the system? The location of the well field, distance to the building, you know, how far is it? It's a lot of questions I'll often ask back, is how far is it to the building? You know, is it quite distance? Is it a, you know, I guess just is the distance, how far is the well field away? On locations for vaults, there's all sorts of location for vaults. I'd say a majority of the vaults go into parking lots. I don't know if it'd be all of them, probably 50% of them, maybe 60% go under parking lots. That's typically where well fields are done. Grassy fields, this location here on this one is an example. Athletic fields, soccer fields, football fields, baseball fields. All these are locations that vaults can go in and be used. For a football field, track field, I think, you know, here's an example of one that was used. And the only thing that I can see on this slide and that I'd like to talk about is the vault is located such that's by the track. And if we are thinking about safety and other things after the installation, and we've had a job in Iowa where this was an issue, and we moved the vault to underneath the bleachers and put it in the concrete pad that's underneath the bleachers. It's probably a better location for the vault. It adds a little bit more distance for the headering and bringing the circuits to the vault, but it does, you know, create a better safety net for if there's a player that falls down or if something happens in the field of play. There's not a manway lid or a metal lid that's over top of the vault that's could get run into or cause some, you know, injuries to the person. Here's an island location for a parking lot. If you look closely, you can, I don't know if you can see my mouse here, but it's in this little island area right off to the side. And then part of the vault is underneath the parking spot. The question I get is about H20 rated, if that needs to be H20 rated. For the temporary loading that's happening there, it's probably doesn't have to be. There's going to be asphalt and gravel above that. The load is not going to be an H20 load there. It will depend. It also depend on the burial depth of the vault itself. Here's some locations for manifolds. You know, on a manifold location, it's all going to depend on how the inside the building and the structure itself, how much space is available, what's the cost of that space, how much is it costing us to build that space, how much room do we have. Here on the picture on the left, it's a picture of the manifold and the project in Iowa. There's a 16-inch main with 28 4-inch circuits. There was a 13-foot gap in between them, and the manifold takes up approximately 42 by 5 foot total area. So that's a pretty significant area. And the building was built such that manifold works good in that area. The picture on the right is a school in Wisconsin, and that project was actually this is actually a vault that is attached to the building. So it's actually like a basement structure. and then there's a walkway, and there's a doorway right beside the mains here that actually allows you access to this large room. I don't know what the cost of that room was. So basically we have a vault here, but it's actually part of the structure itself. And I don't know if it would have been more cost effective to have a vault farther away, closer to the well field, and what the owner wanted there. And that's the other thing too about all these, what I'm talking about today is, sometimes the owner wants different things too, if they want a vault or not, and what kind of access they want to this area. We talk about a little bit about anti-flotation, and any questions you have on that I can answer about, what's the water table? Is it high enough that we need to consider the anti-flotation? A lot of vaults are not in water tables. It depends on the area you're at. There are vaults in the water tables, but as far as we do the calculations for 1 foot below grade, I've never really ran into a situation where a vault is underwater, at 1 foot below grade. Well, is there a need for sump pump and sump basin? I always say that all vaults should have a sump pump and sump basin, just because after the project, it's very muddy, it's very dirty, it needs to be cleaned out and hosed down and washed off. And that sump basin is just a good way to put everything, get everything cleaned out of the vault and get it all ready for service for the owner. Taking a look at the designs, when I do a vault project or when I do all the bidding, I always look at the design and just see if it's, is the design optimal? If I feel like there's something that I could maybe address, I'll call the engineer and talk to him a little bit about it and tell him how, what I think that we could do to improve it, and then get their opinion on what kind of diversity they want. Does the design make sense? Most designs are all good. There's nothing that I see that's really, if it stands out to me, I will contact the engineer. Like I said, how much diversity, are we after? On this design, particular one, this vault went in this way, it's in Nebraska. But, could we have gotten away with 3-inch circuits of 22 bores and then a 6-inch main inside the building? That's kind of the question once in a while I have is if we change the well field just a little bit, go to 3 circuits, is that enough diversity that the engineer feels comfortable if one circuit goes down in the middle of winter time? Can we limp along on the other 2 circuits? Sometimes that answer is no, sometimes that answer is yes. And then if the answer is, yeah, we can live with that, now can we put the manifold inside the building instead of using a vault? Okay, if we look at the distance to the building, how far is the building away? On this particular job, it's 420 feet from the building. Is it still feasible to do an interior manifold? So this job has 2-inch pipe on it. So we have 840 feet of 8-inch DR15.5 with a volume of 1,900 gallons. We have 10,000 feet. If we were to take that 840 feet out and change it with 2-inch pipe and run all the 2-inch lines into the building, and have 10,000 feet of 2-inch DR11 with a volume of 1,550 gallons. So we actually save volume. This job was in North Dakota. We'd save volume, they have glycol in there, so we're saving money if we were to put all the 2-inch in. Now, however, what about the labor to install all the 2-inch lines, dig the trench big enough to run it to the building, and then once we get to the building, do we have enough room to put the manifold in? So, and then what's the price of glycol? Right now, glycol is pretty high priced, as some of the contractors know. Again, if we look at this one, this is a different project. This is one that I was referring to, the well field with the vault in the football field area, playing area. It's 650 feet to the building. Is it still feasible to do an interior manifold on here? Well, it's 1,300 feet of 8-inch pipe with a volume of 2,650 gallons. If we were to replace that, again, this job was 2-inch circuits. We replaced that with 36,400 feet of 2-inch pipe. So you can just see the sheer fusions and volume of pipe that we're going to have to put in the ground to replace. The volume of the 2-inch now is 5,600 gallons versus 2,600 gallons. So if we have a glycol expense, whether there's glycol in the design or not, the 8-inch. So in this case, the vault is needed. It's a practical and justified way of hooking up the well field. And the size, basically the labor to install all that 2-inch pipe is pretty high compared to a 8-inch lines also. Okay, let's look at the possibilities of what if we were to change this and we put all these circuits into 3-inch circuits. So we go 14 3-inch circuits with 8-inch lines, or 18 1-inch loops on each circuit. What does it change? It doesn't change the volume of the 8-inch, but it changes the volume of the 3-inch. We have half as much pipe, so it wouldn't take us the labor to get all that pipe run into the building. Still going to have wide trench, but it's not going to be as wide, and there's going to be fewer fusions, but the volume goes up again, from 5,600 now to 6,900. It can save about $20,000 on the vault if we go to this. So then the question is how does that affect the well field, the number of circuits? I did some quick math on this job just to kind of comparatively say, what if we had 8-inch mains with 28 2-inch circuits? And what if we had 8-inch mains with 14 3-inch circuits? How does that change the overall cost of the well field? In reality, it doesn't change much. So then it would come down to the contractor's opinion. So with the 8-inch vault and 2-inch circuits, the total material cost would be roughly $370,000. The total volume of the system is 14,600 gallons. And the total cost of glycol is about $210,000. And that's just these rough numbers, just based on what people have kind of told me on glycol cost. So that gives us a total project cost of materials only of $575,000 roughly. On a 3-inch, if we did this vault with a 3-inch circuits, 8-inch, the total material cost drops to about $350,000 because the vault's cheaper, but the 3-inch is more expensive, and it all kind of balances out. So we save a little money there, but the volume goes up to 16,300 gallons. So we have about $228,000 in glycol that we need for a total project cost of $578,000. So as you can see, between these two projects, the vault is needed, but so I think that when you look at it, the vault is needed because the sheer labor and everything to get all the lines to the building. And then when you look at the overall of how you change it, from 28 circuits to 14 circuits, is it economical to do it? It looks like they're both the same about cost as far as materials. So then it's labor. And then after that, it depends on how the contractor or the diversity of the well field that the engineer wants. And I'm kind of digging a little bit into that just because I know I'm kind of stretched on time for trying to make this presentation stretched out a little bit. Existing buildings, what are the constraints of an existing building? The size of the existing mechanical room is the biggest constraint. So sometimes it's just an old boiler room or a coal room, and it's very small. There's not a lot of room in there. By the time you put the pumps in there and all the pumps and the units and whatever else they put in the mechanical room, there's not enough room for just even a 3-foot by 4-foot area that we can put a manifold in. So the number of utilities outside can be a factor too. I don't do a lot of work on the coast, but I know that East Coast there's a lot of constraints in between buildings. They got easements and other things that a lot of utilities are running through. So it's just not easier to bring 2 lines in. The same would be true for crawl space. The crawl space could be 100 feet of crawl space. It could come in on one side of the building and go all the way around to the other side before they want to bring a manifold into the room. So running 2 4-inch or 2 6-inch lines in that crawl space is a lot easier than running 8 or 10 or 15, 16 2-inch lines, or 6 or 10 or 8 3-inch lines, depending on the size of your well field. H20 rating. So, you know, we all know that concrete vaults are H20 rated. Can HDPE vaults be load rated? Sheet stock vaults cannot probably be load rated unless a big pad is poured above them, and then there's some loading issues on top of the sheet stock. But cylindrical vaults can be, pipe vaults, and it also depends on the burial depth. So if a vault is cylindrical in size and then it is buried 30 inches deep, not 30 feet, sorry, 30 inches deep, it actually has a natural H20 rating, and we can do the calculations for that and show that through the AASHTO rating, and I'll talk about that a little bit more. Mostly HDPE vaults are buried what we call shallow cover, and if we have a shallow cover and we have an H20 rating or an H20 area that's going to require that, then we're going to need a concrete pad above that, above the vault, such that we can protect the vault from the loading from the vehicles going across it. And live loading is different than H20 loading. So if you have a live load, there's going to be other factors that we're going to have to factor in. We did a job in Canada at the IKEA where they were worried about trucks and stuff sitting there. It could be for a month, they said, or you know, a while, because they haven't been unloaded. They're storing stuff or different things that might be happening. So they were worried a little bit about live loading. So we did some calculations on that and figured out what the live load pad needed to be. Here's just a little example of the American Association of State Highway and Transportation load calculator. We do these load calculations on our vault housings if needed, if required by the engineer or the specifications. So in summary, you know, how far is the loop field from the mechanical room? You know, are there any outside features obstructing the mechanical access to the mechanical room, like a parking lot, water feature, existing building utilities? How much space is available for the manifolding inside the mechanical room? What is the volume of fluid needed using a vault versus an interior manifold? You know, what's the economics look like? And what's the water table? This could be an issue. Is there a requirement of H20 rating? Those are all kind of the questions that you need to ask yourself when it comes to whether we should use a vault or not. And like I said, there's not a lot of, you know, when it comes to how we determine if we need a vault or not, each project is unique in how it's laid out and what the determining factors are and whether you need that external manifold location. So, you know, there's not really any specific answer to the question, I guess. So I'll open up for discussion and answer, you know, questions, and hopefully I can answer your questions. I know that was a quick summary of what, how, or when we use a vault, but I'll take any questions if you have them.
All right, Joe, the first question I'll handle. Adib had asked if the slides would be shared, and the YouTube will, or this will all be posted on YouTube. And so the presentation itself can then be viewed later from that perspective. So you would be able to see the slides again on the recorded version. Second question comes from Courtney. And she asks if you could talk about the use of accessories in vaults, for example, pumps, lights, exhaust, etc. And if there are scenarios that you find them necessary. And then also a follow-up question, are there any areas of the country where the code requires those same accessories?
Okay. All right, so let's just do the codes first. I might have to ask you to repeat the question after I get it. Okay, so as far as codes, I do not believe there are any parts of the country that require that we have lights, fans, or anything, heaters inside of the vault. I'm not aware of any requirements that say that we have to have electricity inside of a geothermal vault. And as far as the accessories go, lights, I'm currently out in Seattle. I'm in my hotel room right now, and it would be nice to have lights inside of the vault that I'm in right now. There are not lights and accessories inside the vault that we are on. So I think it's just I would say that it's a convenience on the lights. The sump pump, I think, is definitely a requirement. There's all sorts of things that happen. There are, vaults that don't leak. They can get them to be leak free. Even on concrete vaults, they can seal them up pretty tight. But the problem is when you go to unhook hoses after flushing and purging, you're in and out with mud. You have a lot of issues trying to get that vault prepared for the customer after everything is all said and done. We have glycol in some of the vaults after they're cleaned out and flush and purge. So I just feel like it'd be nice to have electricity in each vault. And the reason that electricity is there is so they can clean it up, do all your fine tuning and adjustments, and that sump pit will take all those fines and all the mud and dirt and the glycol and get it out of there so you can clean the vault properly. Was there anything else about accessories on it? Oh, the ventilation fan. That's an OSHA requirement for confined space. In a concrete vault, you're going to be a little more susceptible to any contaminants that may be in the soil. There is permeation and stuff like that in the concrete vault. In a HDPE vault, you won't have as many ventilation requirements, but a fan is still required to create positive pressure in the system, inside the vault. Hopefully that answers some of the questions you had.
I think so. Next question comes from Rick and Judy.
Okay.
They would like you to discuss the trade-off between valve boxes and vaults.
Okay, so I always used to have a friendly discussion with my friend and late Kurt Messer. He was a great guy, and we'd always talk about vaults, and he'd always tell me I'm never going to use one. And I understand that, and I understand his point. His point was well taken, and I never really, argued with him on that point. The problem that I have, or the one thing that I asked, if you're in the middle of winter time, a valve box in the wintertime in South Dakota and something happens, you got to go out and try to find that. And that's probably the only thing that I see the difference between a valve box and a geothermal vault. Other than that, they both operate the same. They have you're just trying to isolate the circuits, right? So I get the design, and I understand that design, and it was always a friendly banter that we had back and forth between valve boxes and vaults. So my only argument would be is in the middle of winter time, how are you going to go find it, and dig it up and make sure, and if it doesn't shut off, what's the next step now, hopefully that's just my opinion of it.
Steve asks, what is the life cycle of a concrete vault versus HDPE? And does a concrete vault require special waterproofing?
Yes, it will require special waterproofing because we know that concrete is porous by nature and it will crack. Even if it's reinforced it's just going to have crack. So life cycle cost, that's a great question. So we don't know what the true life cycle of HDPE is. And I think that I've been involved in the industry with both concrete and HDPE. My firm belief is that if you have HDPE loop fields and loops, then why would you not have an HDPE vault? This is, again, my opinion, because the life cycle is the same, right? It's if the loop field lasts 100 years, the vault's going to last 100 years. Now the valving inside most likely won't, but we design our vaults for 50 years, and that's a conservative number. We can probably design for 100, but we do our load rating and all our anti-flotation calculations, all our information that we do on our vaults is for 50 years. I believe that and I'm not an expert on concrete longevity and all that stuff, but I believe that most concrete vaults or concrete structures are 25-year estimated life cycle. I think that's what the concrete industry uses, but I'm not an expert on that, so I don't know. I'd have to defer that exact number to somebody else.
Jeffrey asks, Have the vault mains been designed to allow for bypass of loop connections so as to allow for flushing the mains from the building without contamination of the verticals with debris flushed from the building?
Yeah, the answer to that is yes. And then, so we, at Infra Pipe, and even when I was at ISCO and GHP, at first in the early years, we didn't have a lot of bypasses. A lot of people didn't, they just flushed and purged through the circuits. We hoped that they were doing it correctly, and there was really didn't have many bypasses. When I went to ISCO, I believe, and I think they still do it, and I know we do it. We do it on every vault. Every vault has a bypass equal to the size of the mains. However, if on a larger vault, say if we have an 18-inch main, we can't get the 90 degrees to turn around. So we go with like a 12-inch. We always make our bypasses half the size of the main. And I think I stress that to engineers and to others that we always want that bypass to be at least half the size of the main, because that allows our pumps to flush and purge properly. I also recommend that, and I kind of talk about it off subject a little bit, but I also recommend an H configuration inside the building such that the building can be isolated from the well field. The well field can be isolated from the building. The flush and fill ports are on the middle, so that if something happens and you had to flush and purge from the building out to the vault, you can run it past the bypass and flush it back. There's also flush and fill ports inside of the vault that you can use that, so that you don't have that equipment inside the building. So if you have an H configuration inside the building, you'll be able to flush and purge from the vault to the building. And if you have fill ports on both ends, you can do it either way. That's a big thing that, needs to be talked about, and we do need that bypass in the vaults.
James asks, is there any issues with overheating the football field or soccer field when that much pipe is placed underneath? And have you ran into this problem?
I've never ran into that problem, so I can't answer that question. Tyler, I guess you'd be better at answering that question, but I don't believe there's an issue there. No. In the wintertime, that ground's going to be frozen just deeper. And I think that the thermal effects from the sun and some other things aren't going to really affect the surface area so much as the depth. But that's just my, thinking.
I personally have not run into a project that's had that happen. I'm not saying it couldn't in theory, but I personally have not ran across one.
Yeah, and I haven't either.
Rick has asked, what is the air change rate inside the vault? I'm guessing he's referring to the ventilation fans or the pressurization due to OSHA. Is there a requirement for air change rate?
Yeah, I don't know. That's a good question. I guess I'll have to think about that. I'll have to ask somebody about that. We just want positive pressure. So we know that the ventilation fan has to have like so many CFM, and off the top of my head, I don't know that. I'd have to look at some of the information, but it has to have so many CFM to create positive pressure. So like when you can feel the air moving out of the manway as it blows. I'll get an answer to that question.
Okay. Courtney has a follow-up regarding ventilation as well.
Okay.
Would the use of just confined space equipment, including fans and ventilation, be sufficient instead of a permanently installed fan in the vault?
Yes, that's what I actually recommend. If in my opinion, and I've had a discussion with some people, and after I got off the phone, I called OSHA and I talked to them. And when I talked to OSHA, they said that fan has to create positive pressure. If the fan is inside the vault, it is drawing air in because it has to have an inlet, right? So even if you have a duct, some people will put a neck on one end of the vault, put the fan inside, and then use the fan to blow out the other side. Even if you have this, you are still drawing air into the vault. So the fan is inside. So if there's a generator nearby working or something like that, it's still sucking air in, and that contaminant can go inside there. So the ventilation fan has to be outside of the vault, create a positive air pressure inside the vault such that it lifts the contaminants out. And a lot of that comes from the sewer industry and how they work when they're in in confined spaces in sewer. So that's a good way to think about it also. If you think if this is a sewer app, if it's an application with sewer, you wouldn't put the fan inside the sewer system and then go in there. And hopefully that makes sense.
John states, nice work, Joe. Great considerations. His question is, do you have discussions that factor in the show and tell value to the project and the industry when considering an interior mechanical room manifold instead of a vault?
Okay, so let me clarify this. So he's asking if somebody's going to come look at this and say, oh yeah, there's value to that manifold being there because they're going to use it as a showpiece. If that's what he's saying, then yeah, I mean, there is some value to that. I think that it's kind of impressive to walk in. You go back to, this slide right here, this manifold, this Iowa project, both these manifolds actually in Wisconsin and Iowa, very impressive manifolds, and they are very visible to the public. So yes, I mean, if it's something that the council, now we have residential homes that have vaults in them for that exact opposite reason. They'll say, I don't want any of that in my mechanical room. I want a nice clean 2 lines coming in. So they'll put vaults in small projects just because of that. So like I said, each project, so when I was asked to do this presentation about when is it needed, it's just honestly, it has always been like each project is individual and unique in its own aspect.
Oh, that's exactly what he's referring to, because his second part was so much of the technology is not visible. And he wants to make sure if we're going to take that visible show and tell, so to speak, away, he wanted to, he's asking, the math needs to work well enough to make that argument.
Yep, exactly. And I've talked myself out of more vaults than I've ever sold, just so everybody knows. So, because I think that there is some advantage to having a manifold inside. I mean, there are times when vaults are necessary, but like I said, I've talked myself out of more vaults than I've sold. So.
Could you comment on valve or equipment materials for long-term corrosion control in the damp environment?
Yeah, I think that, it comes down to cost. The valves that we use are, fairly cheap and inexpensive. If you change to a PVC valve or something like that, it's going to cost a lot more money. It's probably, I don't know if it's worth it or not. Then you talk about stainless steel backup rings. The environment is such, I haven't, in the time that I've heard of a couple vaults having some problems and changing out some stuff, but in the last 18 years, I just really haven't had any issues with changing out valves because of corrosion or anything. Now, I've been in some valves where they're pretty nasty, or vaults where they're pretty nasty looking, but the valves are still in pretty good shape. So I don't know if it's economical to change that out to a more high expensive, stainless steel backup rings, all stainless steel valves. It's definitely not. Stainless steel valves are 4 or 5 times the cost. I don't know if PVC, I think I want to say it's 2 times the cost. HDPE ball valves, I don't recommend, because if they fail or something happens, if they're not totally open, they can have some issues. If they fail, you got to cut them out and re-put them in. And that's when the problem, that's the hardest part, is after the fact.
That was Courtney's fault. Courtney had a follow-up question regarding that. What about HDPE valves? And then she also asks, comparing fusible versus flanged. Yeah,
I like flange connection. These just simply because it's easy to replace. If it's made, if it can fail, it's probably going to fail. So I think that easy replacement and maintenance is an issue. So we want to be able to replace that valve easily. And when you're inside of a vault, that even if this picture of the manifold, it's hard to change a valve in a manifold system. So if something happens on the HDPE and they can't get that ball valve to shut inside there, because it's a nylon ball, it's about impossible. You're gonna have to electrofuse it, and then you're gonna start looking at, it's gonna start looking pretty gaudy if you have to take that valve out, put new stuff in, electrofuse it in. It won't look as clean cut. So I like flange connections.
Arlene asks, can you please repeat the certification that you have? I think that I heard Macro Fusion certified. Is that correct?
No, I took the McElroy Fusion class and I'm certified on small diameter up to 20-inch fusion. I've done the IGSHPA classes, so I do all the small socket fusion, you know. So I've been working with this for about 20 years. So I'm just certified on larger diameter pipes.
Okay. And then she follows up with, what are the trade skills needed to do this work? I'm thinking of the type, necessary certifications, or required training to offer.
As far as geothermal vault work, we have certifications. Our guys are certified to the German standard for extrusion welding. So that you have to have a certification for extrusion welding on the housing and stuff for the HDPE housing. I don't know if I have a picture there, right there. So these are all put together with extrusion welding, and it's a specialty process. The machines are fairly expensive, and then you have HDPE cord. It's not a hard process, but it is a specialty process, and there is certifications for doing extrusion welding. As far as the manifold and stuff, IGSHPA, I think, has their certifications, but McElroy has sidewall and small diameter and butt fusion certifications that you have to renew every 3 years. But IGSHPA has we do have our own standards there too, with the IGSHPA fusion certificates, deal with small diameter.
So when we consider location of a vault, we touched briefly on the project with the football field in which it had to be moved underneath the bleachers. If we just speak in general terms of typical location, things we need to consider, could you elaborate on that a little bit?
Yeah, I think that, you know, I've been in, so I just was in a project in Iowa. There's a vault that they wanted to add on to. It's in the middle of the playground, and the manway is sticking up 6 or 7 inches. And I just feel like it's kind of an unsafe area for the vault to be in. Now, I think that it needs to be sloped to the vault lid, and then a manway or cover over top of that lid. But the vault lid should be at grade, not sticking up. If there's any way we can put it in, when it comes to parking lot applications, I feel like the best location is an island or underneath a parking spot. You can go, that this is grassy area here. It doesn't look like it's a playing field. It looks like there's a softball field over here to the right. Again, here's the track. Here's the island situation. You could also put it underneath the parking spot in these corners. Anything in the parking lot, we can cover and protect. Anytime it's in a grassy area, I want to think about what's that grassy area going to be used for, and how can we protect somebody from tripping over it. Is it a trip hazard if it's sticking up too high? That answers the question.
One other question would be, when the water table is an issue, what are steps to remedy or overcoming high water table issues?
Okay, so if we go back to this slide right here, we actually, do the calculations, make sure that we put concrete on the feet. Now, one thing that is important to stress is these vaults will float, and I've even seen a concrete vault float in an open trench. So these calculations are done based on backfilled, the vault being completely installed. So if we see some kind of rain event or high water event that's going to happen during installation, we need to make sure that that dewatering is done until this is backfilled and properly anchored to the, anchored in place. So does that answer your question there, right?
And then just a few comments. James, who had asked the question about the fields overheating, mentions that this has apparently happened in Minnesota. It involves a college.
Okay.
And then Mark states that they frequently use HDPE valves, but we have had some where the brass cracked, and it's a bit challenging to correct.
Okay.
Go ahead.
I've been wondering if that was because of temperature or why the valve cracked, but okay.
And then Terry Profer asked regarding the question when a vault is appropriate, and he answered his own question with, I think the answer to when a vault's appropriate is when a result when a vault resolves one or more problems that otherwise would be more of a problem merely by running headers into a mechanical room.
Yeah, exactly. That's a good way to state it, Terry. That's perfect.
If there are no other questions at this time, I think we're almost to time. And so I think we can conclude if there are no further questions. One last statement from Mark. Sounds like the brass valves cracked due to imperfect manufacturing.
Okay. All right. So there was a reason that happened. Okay. Just out of curiosity, because I don't see that happen very often. I have seen it where they freeze and crack. You know, they got water in them and they freeze and crack, but it's the vault that was left off or something was, you know, there was some external factor that happened to that. So, okay.
Sure,
Well, I hope I helped, I helped in a few ways and made some questions or help people think about different scenarios and why we need a vault and when we need a vault. And if you ever need to contact me, that'd be fine. So appreciate everybody's time.
All right, guys, everybody have a nice week. We appreciate your time and look out for the next Dig Deeper or IGSHPA webinar. Thank you.